Hey, what's going on, guys? Mr. Flores here, and this is a video that deals with solving quadratic functions graphically. All right. So basically, what this video is going to be doing is we're going to be solving quadratic functions, which is a really big idea in Algebra 2 and really math in general, pre-calc, calculus. As you get up there, you got to do it a lot. And normally the way we do that is we solve them by factoring, okay? Before we get into that, though, since we're graphing quadratic functions, we're going to solve them graphically, okay? And some of the different ways that we solve them, when you're solving them, you're looking for the roots, zeros, x-intercepts, or the solutions, really. And these are four different terms that all really mean the same thing. Okay, when you're factoring, you usually call it roots. When you're talking about graphing it, they're the zeros or x-intercepts. When you're talking about factoring, it's sometimes also called a solution. Okay, and in reality, all that solving a quadratic function is you're going to take some equation. Okay, so let's say we have ax squared plus bx plus c, okay? And when you solve it, or you find an x-intercept, or you find the zeros, you're really just setting it equal to 0. Okay? So, basically, all you're doing is setting it equal to 0. So, when you want to look at that graphically, that really is just the two coordinates on the x-axis, the two coordinates where your graph crosses the x-axis. So for this one, here's one x coordinate, or x-intercept, so that's negative 1, 2, 3, negative 6, comma 0. And this one is negative 1, comma 0. Okay, so the zeros, or roots, or solutions for this quadratic would be negative 6 and negative 1, because that's where this graph crosses the x-axis. Okay, so really all that this is doing is it incorporates another thing we have to find when we're graphing quadratic functions. You want to find the zero, the roots, or when it touches the x-axis. Okay, so basically all we're going to do is we're just going to do an example where we're going to graph this, and then we're going to find its zeros. All right, so here we have an equation, x squared minus 8x plus 15 equals y. All right, so what we're going to do is we're going to start off by first graphing this. So the first thing we have to find is our vertex. Okay, and again, the x-coordinate is negative b over 2a. So for this one, it's going to be negative 8, but it's negative b, so it becomes a positive 8 over 2 times 1, or just 4. So our vertex has an x value of 4 and a y value of 4 squared minus 8 times 4 plus 15. Which is 16 minus 32 plus 15. So the x-intercept is going to be 4, comma 1. I mean, the vertex is going to be 4, comma 1. Okay, so what I'm going to do is I'm first going to plot the x-intercept on the graph at 4, 1, 2, 3, 4, comma 1. All right. Oh, actually, no, that's going to be a negative 1. So, sorry about that. 4, comma, negative 1. Okay. So the next thing we want to do is what's your axis of symmetry? So again, the AOS is going to be the x equals 4, since it's the vertical line that goes through your that's going to go through your vertex. The next thing we want to know, it's going to have a minimum at y equals negative 1, because we know that a is positive, so therefore it's going to be opening upwards. So there's a minimum at y equals negative 1 because it's going to be opening upwards. Okay. The next thing we have to do is find other coordinates. So we'll do 4, negative 1, then let's do 3 and 2, 5 and 6. Okay. So when we substitute 2 into the equation, it's going to become 2 squared minus 8 times 2 plus 15, which is going to be 4 minus 16, which is going to give us 3. So it's going to be 2 comma 3. When we put a 3 in, it's 3 squared minus 8 times 3 plus 15. Okay, so 3 squared is 9. 9 plus 15 is 24. Negative 8 times 3 is 24, so it's going to be 0. Okay, now we plug in a 5. It's going to be 5 squared minus 8 times 5 plus 15. Again, 5 squared is 25, minus 40 is negative 15, plus 15 again is 0. Okay, and we plug 6 in. 6 squared minus 8 times 6 plus 5 plus 15. 6 squared is 36. 8 times 6 is 48. So this is going to come out to positive 3. Okay, and again, that should be right because this is going to be symmetrical. So I'm going to plot our other points. So at 3, we're going to be at 0. And 5, we're going to be at 0. And then at 6, we're going to be at 3. 2, we're going to be at 3. All right, so again, just connect your dots. Make sure it's curving. Don't draw straight lines to each points. And there's our problem. So if we notice, our roots or zeros, okay, is x equals, well, we can look at our table and we know that y is 0 when x is 3 and 5. Or you can look at it graphically and see that it crosses at 3 and 5. Okay, so our vertex is 4, negative 1. The axis of symmetry is x equals 4. The minimum is at y equals negative 1. And our roots and zeros are 3, 5. Okay, the new thing that I'm going to bring into this is we talked about domain and range before. Okay, and we said that the domain is really your input. And your range is your output. Okay, so basically we need to look at our input, which is our x values, and we want to know, is there an x value that our graph stops at in the negative direction and in the positive direction? So if we look here, we know that this line, or this side of the graph, is going left in the x direction forever and ever and ever. Okay, and the word we use forever in math is, that's an 8, but it's supposed to be an infinity symbol. Okay, so our left bound is negative infinity. Okay, and then so it's negative infinity is less than x, and then if we go in the right direction on our graph, it's also never going to stop because this arrow means it goes forever. So our domain goes from negative infinity to infinity. Okay, but the y variable, or the range, is a little different, because basically, if we notice, our graph is never going lower than negative 1 on the y direction. So our range is negative 1 is less than or equal to y, which is less than or equal to. If you notice, our graph's going up forever, so it's actually going to go to positive infinity. So your domain is your x's, negative infinity to positive infinity. Your range is your minimum or max, and the other way. So since we have a minimum, it's at negative 1, so it goes from negative 1 to y to positive infinity. If it was opening down, it'd be a little different. All right, but the only two real new things with this video is the domain and range, but then solving it is here because those are our roots or zeros. That's where our graph crosses the x-axis. All right, so I'm going to graph one more just to go over this again. So again, we're going to graph negative x squared plus 6x minus 8 equals y. Again, we need to find our vertex. Okay, so the vertex is, again, a coordinate. It's the max or the min. So x equals negative 6 over 2 times negative 1, which is going to simplify to a positive 3. Okay, so our vertex is 3, comma. Well, we want to plug in 3 for the equation in for x so we can find the y. So it's negative 3 squared plus 6 times 3 minus 8. Okay, so this becomes negative 9 plus 18 minus 8. That comes out to negative 17. So our vertex is 3, 1. Okay, so I'm just going to rewrite it here, 3, 1. And I will draw that on our graph first, which is going to be right there. All right. Next, our axis of symmetry, again, is the vertical line that goes through our vertex. So it's x equals 3, since the vertical line is going up and down. Vertical lines have an equation of x equals 3. Since it has a negative out here, we know that we're going to have a minimum. We're going to have a maximum at y equals 1, because that's where our maximum is at. Okay. And then the last thing, well, basically, in order to find everything else, we just have to graph it. And again, to graph, you put your vertex here, find 2 points less, 2 points more, and we're good to go because it is symmetric. So again, let's find the 1. So I'm going to substitute 1 in for x. All right, and you're going to get 6 minus 8 is -2, minus another one is -3. Substitute a 2 in. Is going to be 6 times 2 is 12, minus 8 is +4. Minus 4 is equal to 0. All right, so the 4 will be 0, and the 5 will be -3. Again, in order to graph this, you just plot your points. So then at 2, we're at 0. At 1, we're at -3. At 4, we're at 0. At 5, we're at -3. So we connect our dots, and we're almost good. The next thing we need is our domain, range, and zeros. Again, your domain is your x values. So if we notice, this is going in the x direction in the negative way. Since it's an arrow, it's actually going to be going this way forever. So your domain is -infinity is less than or equal to x, less than or equal to positive infinity, because this is actually going in the positive x direction forever. Your range is looking at your y values. Since our graph is going down, it's actually going to -infinity in the y direction. But then when you go up, it stops here at +1. So that's your range. You can also look at your max to tell you what your range is going to be. I'll give you a hint. Domain for all quadratic functions are negative infinity to positive infinity, but your range deals with your maximum minimum value. Okay. And again, our zeros is where our graph crosses the x-axis. So we have a zeros at x equals 2 and 4. Okay. Again, you can look at the graph or you can look at your table, and that's really all that you need to know. Just one more quick example. Sometimes when you graph these, it doesn't come out perfect. So let's say we're graphing this equation here. And let's just say it looks like that. Okay. Basically, what you would say here for your zeros, basically it's going to, the 1, 0 is between 0 and 1. And then the other one you could say is between 1, 2, 3, 4, 5, and 6. Basically, the zeros are fractions. They're decimals. They're in between two whole numbers. So you can just say that the zeros are between 0 and 1 and between 5 and 6. That's fine. When we do factoring, we're going to do something called the quadratic formula, which is going to show us and give us an exact value for it. So that's totally fine. The other scenario you could come out with is what happens if our graph never touches the x-axis. For instance, let's say the vertex is here and our graph opens downwards. Okay, that's perfectly fine. You would just say your zeros is just none, because there's no zeros where this graph is crossing the x-axis. Okay, this is another scenario where there technically are zeros, but they deal with imaginary numbers, something we haven't done yet. So for our instance right now, you wouldn't be able to factor this equation if I gave you the equation for this. Just note there's no zeros if the graph does not cross the x-axis, which is totally fine because neither of these are going to be crossing the x-axis. Okay, because this one's going to be opening upwards, this one's opening downwards, neither of them cross the x-axis, so the zeros for these are none. And again, if it comes in between integers, just say between 0 and 1, between 5 and 6. All right, hopefully this helped you out. Again, it's just a quick recap of graphing, except one little added thing with the zeros. The concept or the idea of solving quadratic functions is what we actually did. So when you find the zeros, you're solving it. And again, this is a big idea we're going to tackle later on.